Hello everyone, today we'll be presenting our hybrid rocket engine ignition and control senior project. We are the avionics team for the Unh Seds Club and we will be presenting our final project. This is brought to you by Ben Letourneau, Trevor Blambeed, Meg Johnson, and Thomas Van.
Today we're going to be going over the four main sections of the avionics team: the launch control module, the wireless control and communication systems, the ignition system, and the flow regulation system.
So to get started, we have a quick hot fire test that we'd like to show you. This was the last meeting the group had before we went on spring break and then subsequently coronavirus vacation. And moving along.
So for our project, we constructed a launch control module out of a briefcase that we then put 3D printed inserts in. So that way the components would be below and you would just see a nice clean 3D print. We then put an 11-inch LED screen at the top. So that way we could record and see all of our results through the screen. We also put in LEDs for each launch switch for each individual action, which we'll talk about later. These LEDs would prove that the circuit was working and that we could successfully go forward with the launch. We also used a portable battery of 5 volts for this launch control module, and we have a wireless keyboard and mouse pad in order to work with the screen. For the interior, our Raspberry Pi was our primary computer working within the launch control module. On this, Altus Metrum allowed for GPS tracking and live feedback, which we were unfortunately unable to use due to COVID-19. We also used a wireless transmission to go through the flow regulation system and a software-based backup control in order to control all the functions wirelessly from the launch control module.
So moving on to the Raspberry Pi, we had a Raspberry Pi 4 that we loaded up with Raspbian. The Raspberry Pi was actively cooled by 2 fans because it would be in a briefcase in Nevada or Arizona, and we wanted to make sure that the Raspberry Pi would continue to work in hotter conditions. And then the Raspberry Pi takes inputs from the keyboard and mouse or from the GPIO pins, which were connected to the key switches and whatnot in order to move the signal along from the Raspberry Pi to the XB. And now we had the XB wireless transmitters. We had 2 of them. We set them up to be one be a transmitter and one be a receiver. However, the communication works both ways. They communicate via the serial port, and through testing, they were able to communicate over 300 meters away, and they only started having issues once line of sight was lost.
All right. None of this senior project could have been done without the ignition system. The ignition system included an Arduino, a couple relay modules, a 22.2 volt LiPo battery, a Raspberry Pi 4, and a breadboard. So the ignition system controls were launched through the launch control module through an Arduino, and there were multiple means of safety that were implemented into the system. These safety measures include an ignition sequence, an abort sequence, and a halt, as well as a couple of LEDs and buzzers to show when certain steps of the launch sequence were live. There was a 50-foot wire that was attached to an igniter, and that wire was also implemented into the breadboard.
So moving on to the first version of the flow regulation hardware. This hardware started in the 2018-2019 academic year, and then moved through the summer of 2019 and into the fall. And we used a hardwired ignition box for before we had the wireless transmission working, and utilized a stepper motor to control the flow of oxidizer through the combustion chamber. And we moved on from the stepper motor primarily due to the issues with its reliability in timing. And then after that, we moved into the second version of the flow regulation system. And this is when we moved into the wireless communication between the launch control module and the electronics on the rocket. And this is where we also implemented the three distinct functions of ignition, abort, and halt. The ignition sequence would first set off an E-match, which would heat up the solid fuel within the combustion chamber, and then it would open up one of the two solenoid valves that we were using to allow oxidizer flow through the system. Then we also had the abort sequence, which would dump all the oxidizer fuel out the side of the rocket. That way we could safely approach the rocket should some unforeseen event happen needing to cancel the launch. And our third and final function is the halt, which would stop all flow through all solenoid valves so we could save money in case we needed to stop a test. Then we also had the solenoid valves that were controlling this system. And these were powered by a 22.2 volt LiPo battery and were timed using an Arduino. And then finally, we also had an altitude projection system, which was run through the Arduino using an IMU and an altimeter to measure the acceleration of the rocket, the current altitude of the rocket, and the current speed of the rocket to project the apogee of the rocket given a stop of thrust.
Due to some unforeseen circumstances, our senior project unfortunately had to come to a halt. Of course, I am talking about COVID-19. We had the idea of some future work that could be implemented into our hybrid engine rocket, and this includes improving the robustness of all systems, implementing the altitude projection control algorithm, and implementing the live feedback of the rocket while it's in flight. Thank you for tuning in to our presentation, and hope all is well.